Welcome to the deep dive. Today, we're going to be taking a look at data analysis.
Okay.
A big topic, obviously.
It is.
You've sent us a bunch of stuff on this.
I have, yeah.
And it's one of those things that everybody's kind of dealing with in one way or another.
Absolutely. Like everyone's kind of drowning in data these days.
Yeah. And we're hoping that by the end of this deep dive, you'll know not just what it is,
Right.
but why it matters
Yeah.
and who the players are.
Definitely the key players involved.
I think one of the things that kind of surprised me, actually, going through this material, was that most companies, like, they're gathering all this data,
Yeah.
but they're really not doing very much with it.
That's right. I mean, I think one of the articles mentioned that, like, less than half of the data that's actually captured is actually, like, being used to its full potential.
So it's like
a huge missed out.
it's like having this, like, gold mine in your backyard,
Right.
but you're just, like, using it to grow potatoes or something.
Exactly. You've got this wealth of information just sitting there, and you're not doing anything with it.
So I guess the first question is, like, what is data analysis?
Okay. So data analysis basically it's the process of taking all that raw data,
Right.
Cleaning it, organizing it, and then turning it into something meaningful, basically.
Okay.
Extracting insights that you can actually use.
So it's kind of like, I don't know.
It's like taking a big, messy pile of puzzle pieces and putting them together to form a picture.
Yeah, like almost like panning for gold, right?
Exactly. You've got this whole river of data, but you need the right tools and techniques to find those nuggets of valuable information.
Right. And those nuggets, they can be pretty valuable.
They can be extremely valuable. They can help businesses make better decisions.
Okay.
Optimize their operations, develop new products and services.
So it's not just about making, like, pretty graphs and charts.
No, it's not just about pretty visuals. It's about actually extracting insights that can drive action.
Right.
And improve business outcomes.
But how does it go beyond, like, just the business world?
Yeah, well, data analysis is used everywhere these days.
Right.
One of the big areas is healthcare.
Okay.
Like, I was reading this fascinating study you sent about how machine learning algorithms can actually, be used to analyze medical images and detect cancer.
Right.
And they're actually doing it with even greater accuracy than, experienced radiologists.
So the algorithms are, like, better at spotting cancer than people.
In some cases, yeah.
Wow, that's kind of mind-blowing.
It is. It's a little scary, but it shows you the potential
Right.
of data analysis in healthcare.
Right. So I guess, like, is data analysis kind of like a universal language?
I think it is. It's a tool that you can use to solve problems, unlock insights, across so many different fields.
But before we get too far ahead of ourselves, I think we should
Yeah.
talk about the different types of data analysis. One of the articles you sent mentioned 5 types.
Right. There's descriptive, diagnostic, predictive, prescriptive, and cognitive analytics.
And those all kind of, like, build on each other, right?
They do, yeah.
So what's the first one, like descriptive, what's that about?
So descriptive analytics, it's basically like looking in the rearview mirror.
Okay.
It's about understanding the past. It's like,
Okay.
what were our most popular products last month? Or like, what were our sales trends over the past year?
So it's like summarizing what's already happened.
Exactly. It's like getting a snapshot of the past.
So what if you want to go a little deeper and understand WHY something happened?
Well, that's where diagnostic analytics comes in.
Okay.
So diagnostic analytics is about digging into the why behind the what.
Okay.
So let's say, you notice a drop in website traffic.
Mm-hmm.
Diagnostic analytics can help you figure out why that happened. Like, maybe there was a change in your website design, or maybe there was a competitor that launched a new product.
Right.
So it helps you kind of like pinpoint the root cause of a trend.
So it's like being a data detective.
Exactly. You're looking for clues and patterns to understand what's driving the data.
All right. Well, what about predicting the future?
Right.
Everybody wants to know what's going to happen next.
Of course, that's where predictive analytics comes in.
Okay.
So predictive analytics is about using historical data to forecast what might happen in the future.
Okay.
Like, have you ever noticed how Netflix recommends movies that you might like?
Yeah.
That's predictive analytics in action.
Oh.
They're using your past viewing habits to predict what you might enjoy watching next.
Okay.
And businesses use this all the time to, like, forecast sales, manage inventory, identify potential risks.
Okay, so predictive, all right, so we've got descriptive, diagnostic, predictive. What about prescriptive analytics?
So prescriptive analytics goes one step further. It's not just about predicting what might happen.
Okay.
It's about recommending actions to take based on those predictions.
Okay, so it's like a to-do list for your data.
Kinda, yeah. It's like having a data-driven advisor telling you what steps to take
Oh,
to achieve your goals.
right. And then the last one, cognitive.
Right.
That sounds like the most
Yeah, it's the most advanced.
complicated one.
It is. It's basically using, like, artificial intelligence and machine learning
Okay.
to try to mimic, like, human cognitive processes.
So it's like AI is doing the data analysis for you.
Essentially, yeah.
Okay, like a customer service bot or something.
Exactly. A chat bot that can not only answer your questions, but also, understand the context of your request, learn from past interactions, anticipate your needs.
Right. So, but who are the people actually doing this? Like, behind all this data magic?
Yeah, it's not just robots.
Right.
It's a whole team of people.
Right.
You've got your business analysts, your data engineers, data scientists, database administrators.
Okay, a lot of titles there.
It is a lot, yeah.
Who does what?
So, like, a business analyst is kind of like the bridge between the business world
Okay.
and the data world. They understand the business needs.
Okay.
They translate those into, like, data requirements, and then they kind of help interpret the results
Okay.
back to the business.
So they're like the translators.
Yeah, you could say that.
Okay, what about the data analysts themselves?
So data analysts are the ones who actually get their hands dirty with the data.
Okay.
They're the ones cleaning it, transforming it, modeling it.
Right.
They use statistical techniques,
Right.
visualization tools to try to find insights and patterns.
Okay, and then what about the data engineers, data scientists?
So data engineers, they build and maintain the infrastructure
Right.
that allows data to flow from different sources to the systems where it can be analyzed.
Okay.
They're kind of like the architects and plumbers of the data world.
They build the pipes?
They make sure the data is flowing smoothly.
What about the data scientists? They sound kind of like the rock stars.
Yeah, they get a lot of the hype.
Right.
Data scientists use, like, really advanced statistical techniques, machine learning algorithms,
Okay.
even deep learning to, like, extract those deeper insights and predictions from the data.
Okay, so let's focus on data analysts for a second.
Okay.
They seem to have a lot on their plate.
They do.
What are the key tasks that they're doing?
So think of it as, like, a 5-step process. Prepare, model, visualize, analyze, and manage.
Okay, so what does prepare mean? What are they doing there?
So just like a chef has to prep ingredients before they start cooking,
Right.
a data analyst has to clean and prepare the data before they can analyze it.
Oh.
So they're dealing with missing values, correcting errors, and basically transforming the data
Okay.
into a format that's suitable for analysis.
So they're making sure that the data is like high quality
Exactly.
before they start working with it.
Because the quality of your analysis is only as good as the quality of your data.
Right, garbage in, garbage out.
Exactly.
Okay, so once the data is prepped, what's next?
So then comes modeling.
Okay.
So in this stage, the data analyst builds a model that represents
Okay.
the relationships between different data points.
Okay.
And this model helps kind of organize the data,
Right.
make it easier to analyze and draw conclusions from.
So they're building like a blueprint of the data.
Yeah, it's like a map of the data that shows how all the pieces connect.
Okay, and then what's visualize?
So visualizing the data means creating charts, graphs, dashboards,
Right.
all those visual representations that help bring the data to life.
That's where the storytelling comes in.
Exactly.
Hmm.
Visualizations help us see patterns and trends
Okay.
that might be hidden in raw data.
Okay, so we've prepped the data, we've built a model,
Mm-hmm.
we've made some pretty pictures. What's next?
Then comes the fun part, analyze.
Okay.
So this is where the data analyst actually uses their analytical skills, statistical techniques to identify patterns, trends, outliers, correlations in the data.
So they're looking for those like aha moments.
Exactly. They're trying to uncover those hidden insights that can,
Right.
answer questions, solve problems.
Okay, and the last part, manage. What is that?
So managing data is all about documenting the analysis process,
Okay.
ensuring data quality, security, and basically archiving the data for future use.
Okay, so they're making sure it's organized and accessible for later on.
Right. It's about maintaining the data so it can be used effectively in the future.
Okay.
Good data management is essential for any organization that wants to be data-driven.
So what are some of the biggest challenges that data analysts face? What makes this job so tricky?
Well, one of the biggest challenges is definitely dealing with messy data.
Okay.
Real-world data is rarely perfect.
Right.
It's often incomplete, inconsistent, it has errors,
Hmm.
and cleaning and preparing that data can be a really time-consuming process.
So it's not always as glamorous as it sounds.
No, it's not always about building fancy models and creating stunning visualizations.
Sometimes it's just grunt work.
Sometimes it's just rote work.
Okay, so what else is challenging for data analysts?
Well, another challenge is communicating the findings effectively.
Okay.
It's one thing to uncover insights from data,
Mm-hmm.
but it's another thing to be able to explain those insights to people who may not be data experts.
So they need to be good storytellers, not just number crunchers.
Exactly. Data storytelling is a crucial skill for any data analyst.
Okay, so what skills do data analysts need to be successful in their roles?
Well, obviously, they need a strong foundation in statistics and data analysis techniques,
Mm-hmm.
but they also need excellent communication skills, problem-solving skills, and a healthy dose of curiosity.
Okay.
And increasingly, they also need some programming skills and some understanding of machine learning.
So it's a pretty demanding field.
It is, but it's also incredibly rewarding.
Wow.
If you're someone who enjoys solving problems and working with data, it can be a really fulfilling career path.
Okay, well, what are some of the most exciting things happening in the field right now?
Well, I think one of the most exciting areas is the use of artificial intelligence and machine learning.
Huh?
These technologies are allowing us to analyze massive data nets
Right.
more quickly and accurately than ever before.
Okay, so it's like AI is giving data analysis superpowers.
Exactly. It's like having a superpowered assistant that can help you find insights
Wow.
that would have been impossible to find before.
Okay, but with all this power comes responsibility, right?
Yeah,
What are some of the ethical considerations?
absolutely. Data analysis has the potential to be used for good or for bad.
Mm-hmm.
So we need to be really careful about how we collect, analyze, and use data.
Right.
We need to be mindful of potential biases.
Right.
We need to protect individual privacy.
Right.
And we need to make sure that the insights we're generating are actually benefiting society as a whole.
Yeah. So it's a double-edged sword. It can be used for good, but it can also be misused.
Absolutely.
So what does the future hold for data analysis? What's on the horizon?
That's a great question, and one we'll be diving into in our next segment.
Okay, well, don't go anywhere. We'll be right back.
Stay tuned.
Welcome back to the Deep Dive. Before we get too futuristic with all this, you sent over this really interesting case study
Yeah.
about a major airline using data analysis to
Oh.
improve their operations.
That's a great one.
And I thought it might be helpful to actually see these different types of analysis
Right.
in action in the real world.
Absolutely. And I think the airline industry is a really good example because
Oh.
they have such complex systems and there's so much data involved. And, this particular case study focused on how they used data analysis to try to, reduce flight delays.
Which is something we can all appreciate.
Yeah, I think we've all been there.
Right. Stuck at the gate, wondering when we're going to take off.
Absolutely. So in this case, they started by using descriptive analytics
Okay.
to look at the historical patterns of delays. They looked at data on weather conditions, air traffic control, mechanical issues,
Yeah.
even things like crew scheduling and baggage handling.
So they were trying to figure out where the bottlenecks were.
Exactly. They were trying to identify those common causes of delays.
Right.
And then they took it a step further with diagnostic analytics.
Okay.
And they started digging deeper into okay, why are these delays happening? For example, maybe they found that delays due to mechanical issues
Right.
were more common on certain types of aircraft,
Okay.
or that baggage handling delays were more frequent at certain airports.
So not just identifying the what, but the why.
Right, exactly. Getting to the root cause of the issue.
Okay.
And then once they kind of had a handle on the causes, they could start using predictive analytics
Okay.
to try to anticipate potential problems.
Right.
So, for example, if they know that there's a thunderstorm coming in,
Right.
they might proactively adjust flight schedules or allocate more ground crew to kind of minimize those delays.
So they're using data to kind of get ahead of the game.
Exactly, being proactive rather than reactive.
Right. And where does prescriptive analytics fit into this whole thing?
So prescriptive analytics would then recommend like very specific actions to take.
Okay.
Based on those predictions, like it might say, okay, you need to reroute this flight, or you need to adjust the crew schedule, or
Right.
maybe you need to like pre-position some spare parts at this particular airport.
So it's like having a data-driven air traffic controller,
Exactly. Yeah.
trying to make everything run smoothly.
Keep those planes moving.
And could cognitive analytics play a role in this?
Oh, absolutely. Imagine like an AI-powered system that's constantly monitoring like real-time data from weather sensors, air traffic control,
Right.
even social media feeds
Wow.
to try to like detect emerging patterns and predict disruptions even more accurately.
It's like having a crystal ball for air travel.
It's pretty amazing what they can do with data these days.
All right, well, let's shift gears a bit here
Okay.
and talk about something that I think is on a lot of our listeners' minds,
Yeah.
which is careers in data analysis,
Right.
because it's definitely a hot field,
It is.
but there's a lot of confusion about the different paths available.
Absolutely. Yeah, there's all these different titles.
Right, data analyst, data scientist, data engineer.
It can be hard to know, like, what's the difference?
So what are some of the key things that people should consider when they're
Yeah.
thinking about going down this path?
So the first thing to remember is that, like, those roles aren't always, like, super clearly defined.
Right.
There's a lot of overlap.
Right.
But generally speaking, like, a data analyst is going to focus on, like, extracting insights from the data
Okay.
and communicating those insights to stakeholders.
Okay.
So they need to be good at data visualization, statistical analysis, and storytelling.
So they're kind of like the data detectives and the data reporters.
Exactly. They got to be able to both find the story and tell the story.
All right, and what about data scientists?
So data scientists, they tend to have a stronger focus on like building more complex models,
No.
developing algorithms, using machine learning
Right.
to kind of extract like those deeper insights and predictions.
So more on the like technical side of things.
Yeah, they often have a background in computer science or statistics
Right.
or mathematics.
And then the data engineers, they're kind of like the...
Yeah, the data engineers are all about building and maintaining the infrastructure
Right.
that allows data to flow from different sources to the systems where it can be analyzed.
So like the plumbers and the electricians of the data world.
Exactly. They make sure all the data pipes are connected and the data is flowing smoothly.
And then, of course, you've got the database administrators.
Right. They're the ones managing the databases where all the data is stored.
Okay, so a lot of different roles.
It takes a village to make data analysis happen.
So what advice would you give to somebody who's just starting out?
First and foremost, I would say like build a strong foundation in
Okay.
statistics and data analysis techniques.
Okay.
There's tons of online courses and resources available these days.
Learn.
You don't necessarily need to go back to school for it.
Mm-hmm.
And then once you have those basics down, just start practicing. Get your hands dirty with some real data.
So it's like learning an instrument. You got to practice.
Exactly. You got to put in the time and effort.
Don't be afraid to experiment.
Exactly. Try different tools, explore different data sets, see what works for you.
Now, I think a lot of people get intimidated by the
Yeah.
technical side of data analysis. Like
Mhm.
they think they had to be a coding wizard to be successful.
Right. And that's not necessarily true.
Okay.
While coding skills are definitely becoming more important,
Right.
there are also a lot of tools and platforms these days that allow you to analyze data without writing any code.
So you don't have to be a tech genius.
No, you don't need to be a coding expert to get started.
Okay.
The most important things are like curiosity, critical thinking, and a passion for problem solving.
Okay, so the right mindset is more important than the technical skills at the beginning.
I think so, yeah. If you have the right mindset, you can learn the technical skills as you go.
All right, what are some common mistakes people make
Yeah.
when they're just starting out in data analysis?
Okay, one common mistake is jumping into the analysis without really taking the time to understand the data first.
Oh, yeah.
You know, you really need to spend some time exploring the data set, identifying any potential issues,
Right.
cleaning and preparing the data before you even start running any analysis.
So it's like building a house, you got to have a good foundation.
Exactly. If you start building on a shaky foundation, the whole thing's going to fall apart.
So what other mistakes do people make?
Another common one is focusing too much on the tools and techniques and not enough on the business problem they're trying to solve.
Okay, so they get caught up in the technical details.
Yeah. They get lost in the weeds and they forget about the big picture.
Right, and the big picture is like, what problem are we trying to solve with this data?
Exactly. You always want to keep that business question in mind.
Okay, so you got to start with the question
Right. What are we trying to answer? What are we trying to achieve?
and then use the data to help you answer that question.
Exactly. Don't just analyze data for the sake of analyzing data.
All right, there has to be a
There
purpose.
has to be a goal in mind.
Okay, and what's that other mistake you were going to say?
Oh, right. Another big mistake is failing to stay up to date with the latest trends and technologies in the field.
Right.
Data analysis is constantly evolving, new tools, new techniques,
Yeah.
new platforms emerging all the time. You got to stay on top of things.
So it's like any other profession, you got to keep learning.
Absolutely. You can't just learn one thing and then coast for the rest of your career.
You got to be a lifelong learner.
Exactly. You got to be constantly learning and adapting.
But how do you do that? Like, where do you even start?
There are so many great resources available these days.
Right.
Online courses, tutorials, industry blogs, podcasts.
Shameless plug.
Exactly. And also, network with other data professionals,
Okay.
go to conferences, join online communities.
It's about being part of a community.
Absolutely. Learn from each other, share ideas. It's a collaborative field.
All right, well, what are some of the emerging trends that you're excited about
Okay.
in data analysis?
One trend that I'm really excited about is the rise of self-service analytics tools.
What's that?
So these tools are making it easier than ever for non-technical users
Okay.
to access and analyze data.
So you don't need to be like a data scientist to use these tools.
Right, you don't need to be a coding expert.
Okay.
You can just point and click and get insights from your data.
So it's like democratizing data analysis?
Exactly. It's putting the power of data analysis in the hands of everyone.
That's pretty cool.
It is. It's very exciting.
What other trends are you keeping an eye on?
Another big one is the increasing focus on data ethics and privacy.
Right, because as data becomes more valuable,
Mm-hmm.
we need to be more careful about how we use it.
Absolutely. We need to make sure that we're using data responsibly
All right.
and ethically, protecting individual privacy, avoiding bias, making sure that data is being used to benefit society as a whole.
So data analysis isn't just about numbers.
No.
It's about people, too.
It is. It's about using data to make the world a better place.
All right, so what are some of the ethical challenges that are specific to data analysis?
Well, one big challenge is the potential for bias in data and algorithms.
Okay.
Data is often collected and analyzed in ways that reflect existing societal biases, and this can lead to discriminatory outcomes.
Right.
Like, for example, a facial recognition algorithm that's trained on a data set of predominantly white faces
Right.
might be less accurate at recognizing faces of people of color.
So the data analysis can actually perpetuate existing inequalities if we're not careful.
Exactly, and that's why it's so important to be aware of these potential biases
Right.
and to take steps to mitigate them.
Okay, and what about data privacy? What are the challenges there?
Well, as we collect more and more data about individuals, it becomes increasingly important to protect that data from unauthorized access
Right.
and misuse.
So we need to make sure that the data is being used for the purposes it was collected for.
Right, and that individuals have control over their own data.
Okay, so what are some practical steps that data analysts can take
Yeah.
to make sure that they're using data ethically?
Well, I think the most important thing is to just be aware of the ethical implications of their work.
Okay.
They need to ask themselves questions like, where did this data come from?
Mm-hmm.
Who collected it? How was it collected? What are the potential biases in this data?
So they need to be critical thinkers, not just number crunchers.
Exactly. They need to be able to think critically about the data
Right.
and to identify potential ethical issues.
Okay, what about resources for learning more about data ethics?
Oh, there's tons of great resources out there these days. Online courses, articles, professional organizations, conferences.
So there's a lot of information out there.
There is, yeah. You just got to know where to look.
Right, but that's part of the problem, isn't it?
It is.
Like there's so much information.
Yeah.
It can be overwhelming.
It can be very overwhelming, especially for people who are just starting out.
So what advice would you give to someone who's feeling a bit lost?
My advice would be to just start small.
Okay.
Focus on one area at a time.
Okay.
Don't try to learn everything at once.
Right.
Pick a topic that interests you, find a few reputable resources, and start there.
So break it down into manageable chunks.
Exactly. And don't be afraid to ask for help.
Right.
There are lots of online communities and forums where you can connect with other data professionals.
So it's a collaborative field.
It is, very much so.
So what are some of the qualities that make someone a good data analyst, besides the technical skills?
Well, I think curiosity is really important.
Okay.
Good data analysts are naturally curious about the world. They want to understand how things work.
Right.
They're also good problem solvers. They enjoy the challenge of, like, finding insights in data.
So it's not just about being good at math, it's about having a certain mindset.
Exactly. It's about having an analytical mind.
Okay. And what else?
And communication skills are really important.
Okay.
Being able to explain your findings clearly and persuasively,
Right.
both verbally and in writing.
Because data analysis is useless if you can't communicate the insights to others.
Exactly. You got to be able to tell the story.
All right. And any other qualities that you would say are important?
I think being a lifelong learner,
Okay.
always being eager to learn new things, explore new tools, new techniques, stay up to date.
So always be learning, always be growing.
Exactly.
That's great advice.
Yeah. The field is constantly changing, so you got to be willing to change with it.
All right. Well, what are some of the biggest challenges
Okay.
and opportunities you see on the horizon for data analysis?
Well, that's a great question, and one that leads us perfectly into our next segment.
All right. Well, don't go anywhere.
We'll be right back.
Welcome back to the deep dive. So we've talked about a lot of things, but now I want to talk about the future.
Okay. Yeah.
What's coming next?
So one of the really exciting trends that's emerging is this whole idea of real-time data analysis,
Okay.
where you're not just, looking at static reports and dashboards,
Right.
but you're actually analyzing data as it's being generated.
Wow. So it's like constantly monitoring the data.
Exactly. It's like having a finger on the pulse of what's happening right now.
And what kind of impact is that going to have? Like, what are some examples of how that would be useful?
Well, think about industries like, finance or healthcare or transportation. Imagine a financial institution that can, like, instantly detect a fraudulent transaction and prevent it from happening.
Right.
Or a hospital that can, monitor patient vital signs in real time.
Okay.
And maybe even, like, proactively intervene to prevent complications.
So it's all about speed.
Yeah, it's about getting those insights immediately so you can act on them quickly.
But what are the challenges with that, with analyzing data in real time?
Well, one of the biggest challenges is just the sheer volume and velocity of the data.
Okay.
Real-time data streams can be massive.
Mm.
And a lot of traditional data analysis tools just can't keep up.
So we need new technologies to be able to handle that.
Absolutely. We need new technologies and architectures that can handle, like, these high-volume data streams.
And what are some of the things that are being developed to address this challenge?
Well, cloud computing is playing a huge role.
Okay.
Cloud platforms provide the scalability and flexibility
Right.
that you need to handle those massive data streams.
And what about new algorithms? Are there, like, new algorithms being developed?
Yeah, there are, like, new data processing engines and algorithms that are specifically designed for real-time data analysis.
Okay.
These technologies can, like, ingest and process and analyze these data streams in milliseconds.
Wow, so it's getting really fast.
It's incredible how fast this technology is moving.
But with all this data flying around, what about security and privacy?
Right, that's a huge concern, especially with real-time data,
Yeah.
because often those real-time data streams contain very sensitive information, so we need to make sure that that information is protected.
So how do we do that?
Well, it's a combination of technology and policy.
Okay.
On the technology side, you need, strong encryption, access controls.
Right.
And then on the policy side, you need clear guidelines for data access, usage, and storage.
So everybody needs to be on the same page.
Exactly. Everyone needs to understand their responsibilities and be committed to protecting that data.
Let's talk about another trend that's kind of related to this.
Okay.
The Internet of Things. How is data analysis being used to unlock the potential of the IoT?
So the Internet of Things is all about, connecting all these devices
Right. Everything's connected.
to the internet. Right. And all these devices are collecting data.
Right.
And so data analysis is essential for making sense of all that data.
So give me some examples, like how is it actually being used?
Well, in manufacturing, for example,
Okay.
you can have sensors on machines that are collecting data on, performance, temperature, vibration. And that data can be analyzed in real time to detect anomalies, predict maintenance needs.
So you can fix problems before they even happen.
Exactly. You can prevent downtime. You can optimize production processes.
Okay, that's pretty cool. What about other industries?
In the energy sector, smart grids are using data analysis to optimize energy distribution,
Okay.
reduce waste, improve grid reliability. And then in transportation, connected vehicles are collecting all sorts of data
Right.
on traffic patterns, road conditions, driver behavior.
And you can use that data to do what?
Well, you can use it to improve traffic flow.
Right.
make the roads safer and eventually, enable autonomous driving.
So it's really transforming a lot of different industries.
It is. The IoT is generating huge amounts of data,
Mm-hmm.
and data analysis is the key to unlocking the value of that data.
But with all this automation and AI and all these new technologies, are we at risk of losing the human touch in data analysis?
I don't think so. I think, while automation and AI are definitely playing an increasingly important role,
Right.
I think the human element will always be essential.
So it's not about replacing humans with machines.
No, it's about finding the right balance.
Right, it's a partnership.
Exactly. Humans bring critical thinking, creativity, intuition, ethical judgment to the table.
And you need that.
And you need that to really make sense of the data.
So what are some of the skills that are going to be most important for data analysts in the future?
Well, technical skills will always be important, of course,
Okay.
but I think soft skills are going to become even more crucial.
What do you mean by soft skills?
Things like communication, collaboration, critical thinking, problem solving, creativity.
So it's not just about the numbers, it's about being able to work with people.
Exactly. You got to be able to communicate your findings clearly,
Right.
work effectively in teams, think outside the box.
So what advice would you give to someone who's interested in pursuing a career in data analysis?
Well, I would say, first of all, build a strong foundation in math and statistics.
Okay.
Learn some programming languages like Python or R,
Right.
and then just start practicing, find some data sets online and start playing around with them.
But a lot of people get intimidated by the technical side of things.
Yeah, I understand that, but there are a lot of user-friendly tools available these days.
Okay, so you don't need to be a coding expert to get started.
No, not at all. Tools like Tableau and Power BI
Okay.
make it really easy to create visualizations without writing any code.
So it's more accessible than people think.
It is, and there are also lots of cloud-based platforms
Right.
that offer a wide range of data analysis tools.
So there are really no excuses for not getting started.
No, the resources are out there, the demand is there, it's a great field to be in.
So if you're curious about data, you like problem solving,
Hmm.
you want to make a difference in the world, data analysis might be a good fit.
Absolutely. It's a field with a lot of potential.
Well, this has been really eye-opening.
Yeah, it's been a great conversation.
I feel like I have a much better understanding of data analysis now.
Good. I'm glad to hear that.
And thanks to you, our listener, for sending in your stack of sources.
Yeah, thanks for listening.
Keep asking those questions, keep exploring, and maybe you'll be the one to make the next big data-driven discovery. This is The Deep Dive. Signing off.